There is an ideology, or we can say there's a cliche about biostat, that neither the teacher knows what he is teaching, nor the students ever get to know what they are learning. And in my personal opinion, it is because of this confidence interval and how to calculate it. Now, let's change this cliche today. What is confidence interval and how it is different from the confidence level? Now, this is our normal distribution curve, our bell curve, and we mostly know that we use the 95% confidence level. As in the previous video, we have already done this, that at the 95% confidence level, we know that the population mean population mean is within the sample mean, and this is the area which is non rejection area, and these two side areas are the rejection areas. Now, at the 95% confidence level, we know that the population mean mu is within the sample mean, that is the x bar. Now, if it is the confidence level, then what is the confidence interval? Now, confidence interval is an exact calculation. It is an exact calculation that the population mean is within these two limits of the sample mean. Now, how to calculate the confidence interval? Let's simplify what is the confidence interval. At the 95% confidence level, we know that here is x bar, that is the sample mean, and to find out the confidence interval, what we need? We need the values of the z-scores. And the values of z-scores are predetermined, and we can take them from a standardized tables. And at the 95% confidence interval, the z-score is always 1.96. So, now what is the formula for the confidence interval? A very simplified formula of the confidence interval is x bar plus standard of error on the right side, x bar minus standard of the error on the left side, and within them is the confidence interval. So, let's calculate it with an example. Now, if we ask 40 people, now our sample is of 40 people, and we know that the sample should be representative of the population. Obviously, we cannot take the sample of the whole population, so we take a sample that is representative of the population. So, that's the sample mean, that is the x bar, should be a representation of the population mean, that is the mu. So, if we have n is equal to 40 and we ask 40 people for how many hours they watch Netflix in a week. Say for example, for our 40 values, let's say for example, our sample mean is 130. It is 130 hours, and the standard deviation of this mean, say, is 50. Now, we have these set of values, and we already know that for the 95% confidence level, the value of the z is 1.96. Now, this is x bar, this 1.96, it is 1.96. These are our z-score values, 1.96. We have 0.025 here, we have 0.025 here, as we have 5% chances of alpha. And what is alpha? We already know from our previous talk that alpha is the type 1 error. When the null hypothesis was true but it was rejected, it was type 1 error alpha, and that is also called the level of significance. So, now let's continue with our effort to find out what is confidence interval and how to calculate it. Now, For our confidence interval, we need two limited values for the right limit and the left limit. For this, now we already have the value of sample mean, the x bar, that is 130, and now we have to find out the E, that is the margin of error. What is E? E is the margin of error, and the formula for E is ZC, that we already know is 1.96. It is a standardized value and we have standardized tables for it. Multiply by population standard deviation, that is sigma, divided by square root of n. N is the number of sample, and as we know that our sample size is more than 30, so we can use the standard deviation. We can use the standard deviation of this sample as mu, which is the population standard deviation. So we will rewrite it as ZC multiply by standard deviation divided by square root of n. Now we will put the values. E is equal to 1.9650 divided by 40. Obviously we will use the calculator, we cannot use it, do it manually, and it is 16.4. So our n was 40, the sample number was 40, our sample mean was 130, and our SD was 50. And what we were doing? The mean hours for which a person watched Netflix in a week. Now we want the exact values on the right and left, that will be our confidence interval. Now what is our sample mean? Our sample mean was 130. So for our this bar, here we have the sample mean, which is also called the point estimate. It is also called the point estimate. So here we will have x bar minus margin of error. We have already calculated it. Now we have, no, let's draw it here. Here we have the x bar. Here we have on the left side we have x bar minus E. On the right side we have x bar plus E. We have here the value of E. So it is 130 plus 16.4. 130, sorry, on the left side we have 130 minus 16.4. Here we have 130 plus 16 by 4. It is 113.6. Let's round off it to 114, and here it is 146.4. So what is now our confidence interval? We have successfully calculated our confidence interval, and now our confidence interval is between 114 and 146, and our mean was 130. Now at the 95% confidence interval, we can say that for a sample mean value of 130, our population mean, which is mu, is definitely is falling between these two values 114 and 146. Now this is how we calculate the confidence interval. And now what is confidence interval? Confidence interval are the two limits within which the sample mean, that is mu, is present, and these values, these right and left values, they are indicating that how much the two limits are from the sample mean. So what is the confidence interval? The confidence interval is an interval within which the population mean is present, and that is for a sample mean of 130, it is between the 114 and 146.